Hi, my name is John Grimes and I'm an engineer from the Australian eHealth Research Centre, which is the digital health program within CSIRO, Australia's National Science Agency. Today I'm going to be presenting the SQL on FHIR implementation that we are working on as part of Pathling. First, I will give you a bit of an introduction to Pathling, what problem it tries to solve and the different components that it comprises. I will also point you towards where we are working on this feature so that you can follow along as we progress it towards release. Then I'll jump straight into a demonstration of the SQL on FHIR view runner that we have recently added to the implementation. Then I will talk a little bit about the work that is remaining. Pathling is a set of tools built upon Apache Spark that make it easier to use FHIR data for analytic purposes. It includes encoders for reading FHIR data into Spark data frames, terminology functions for integrating with a FHIR terminology server, and a FHIR path implementation for building aggregations and projections of FHIR data. It is delivered as language libraries, and it also has a server implementation. It features language support for Python, R, Java, and Scala. The server provides data ingestion and FHIR path query functionality through a standard FHIR API interface. Pathling is free and open source under the Apache 2 license. The source code is available from GitHub, and we distribute the software as Java, Python, and R libraries. We also publish a server image via Docker Hub. If you want to run the code that I will be running today, you can build the Python library from the branch that is the subject of this pull request. For the demonstration, I'm going to go through a Jupyter Notebook example. Feel free to follow this link if you would like to examine the notebook in more detail. I'm going to be using Databricks as a convenient way to run my notebook, but this code can also be run locally or using any environment that has access to Python and a Java runtime environment. The example we've chosen to demonstrate today relates to prostate cancer risk factors. We're going to create a number of SQL on FHIR views from synthetic patient data to support the analysis of some candidate risk factors. This is what our source ND-JSON data looks like on disk. We have about 11,000 patients, 370,000 conditions, and 2.8 million observations. As a first step, we're going to read in the ND-JSON and save it out to Parquet tables using the Pathling Python API. This step is optional. You can also query directly over the ND-JSON data without any requirement to persist it into an intermediate form. Once we've done this, we can see the tables in Databricks. You can see the format that the Pathling encoders use to represent FHIR within Spark data frames. Now we can read in those tables and start constructing our views. The target view is going to have some patient demographics, along with the date that the patient was first diagnosed with prostate cancer, and the dates of hyperlipidemia and high BMI observations that may have occurred prior to that diagnosis. The patient view is straightforward, no unnesting required. The getResourceKey function is used to create an ID that we can use to join the views together later on. We have left the postal code as an array to show that this is possible. The hyperlipidemia view uses getReferenceKey to construct a foreign key back to the patient view and flattens out the relevant observation details. The where clause is used to filter the observations to only total cholesterol over a certain threshold. BMI is similar. One of the nice things about the Pathling encoders is that they add in canonicalized values for quantities that use UCOM units. This allows us to do comparisons like this that are tolerant to the use of different units where they are comparable. For example, this could work against BMI captured as pounds per square inch. And then we create a view of the condition resource that is filtered to only prostate cancer diagnoses. The task of joining together the views, finding the first diagnosis, getting the most recent observations relative to the diagnosis, and final data type conversion, these are all tasks that are left to generic Spark SQL queries. This query is lazily evaluated and optimized as a single query in Spark SQL, which means that only the required columns need to be retrieved from persistence, and data can be filtered based upon predicates in any part of the broader query. What we end up with is a data frame with 440 rows and 11 columns that can be brought into a pandas data frame at this point. And the remaining analysis can be done using Python in memory. We still have a bit of work to do before we can say that this feature is ready for release. Constants and unions are still on the to-do list. We also have more work to harmonize the SQL on FHIR view runner with the existing FHIR path query operations that are already available within Pathling. We would also like to surface the view functionality within the R library and the server implementation. Thanks for listening to my talk. Please hit the like button if you got something out of this content. And also please subscribe to the channel if you would like further updates about Pathling and our work on SQL on FHIR.